Zenith 8H832 Restoration, Part 2. Tube testing, cleanup, capacitor, and resistor replacement. The first order of business was to check out the existing tubes. As you might recall, the set was missing its 5Y3 rectifier, and I did eventually discover why this was the case. The previous owner installed an old silicon diode across pins 2 and 4 of the 5Y3's socket. Do you see it? Pins 2 and 4 are the connections for one set of anode and cathode in the 5Y3. The 5Y3 is a dual diode or full wave rectifier tube. The set couldn't possibly work like intended with half its rectification missing, so the reason for only adding one diode here is a bit of a puzzler to me. Anyway, I've removed the diode and put the set back to the way the radio gods intended with an NOS 5Y3 rectifier tube from my hoard. Other anomalies with the tubes included a couple of substitutions. One of the 6AU6s was subbed with another tube. I forget the type, but it's unimportant as I've swapped it out with an NOS 6AU6 tube. The 6BE6 converter tube tested is very weak, so it was also replaced with an NOS tube, courtesy of the tube hoard. Here I am checking the metal 6F6 that was installed in the set as the final audio output. This tube had a very baked, charred appearance and looked as though it had seen some rough operating conditions over the years with questionable biasing. Nonetheless, the tube still tested very good, but in the end, it too was a substitution. Originally, this radio had a glass envelope 6V6 as the final audio tube, and so the tube hoard once again provided the correct tube. It really pays to have parts. A brief word about vacuum tube testers here. I've owned all different types of vacuum tube testers over the years, from low-end night emission style testers built from a kit to very high-end Weston tube analyzers and even a Hickok transconductance tester at one point. But in the end, I sold them all off and have settled for this lone Precision Model 10-12 dynamic tube tester from the early 1950s. This piece of test equipment can test an amazing variety of vacuum tubes, and it does so easily and quite reliably, not to mention consistently. As has been said many times before, the best test for any given vacuum tube is installed in the equipment where it's used. Still, I start off all of my restorations with a check of the tubes for shorts and cathode emission. All of the other tubes checked out, so with a full complement of the correct tubes, we're now ready to proceed. Up next is a quick check of the power transformer's primary winding. I do this by stripping off the leftover leads from the power cord and connecting my multimeter set to measure resistance directly across the power cord. As we can see from the schematic of the power supply, this set uses two inductors designated L24 as input filters. The DC resistance of the power transformer primary is about 4 ohms, so coupled with the resistance of L24 and the power switch, which is also directly in the circuit, I would expect to see somewhere in the neighborhood of 10 to 20 ohms. In other words, a very low resistance. The first usage of the AC power switch with mains voltage applied will clean the contacts of the power switch, so I'm not concerned about the variation that we're seeing here where it goes up to 40 or 45 ohms and then down to 13 ohms. The point of this test is to make certain that the primary in the power transformer isn't open, and we've proven that it's not. We expect to see a comparatively low DC resistance here, and that's exactly what we've found. As we can see here, I've connected directly across the power switch, and when switching it on and off, we're seeing fluctuations of DC resistance. And again, that's perfectly normal on a set that's gone unused for so many years. The AC power switch in this set is sealed, so I'm not going to attempt to disassemble it to chemically clean it. I'll just let the AC voltage do that. On to the next quick check. I briefly connect across the volume potentiometer and check that it is not open, and that its wiper is making contact. As I slowly turn the volume control, the resistance changes, so we're good. I didn't get footage of this so as not to bore anyone into a coma, but I sprayed the volume pot and did some in-depth cleaning of the band switch contacts with Keg deoxit and the end of a wooden stick from a medical cotton swab. You want to avoid soaking the wafers of antique radio band switches with the cleaning solvent where at all possible, so my method is to simply dip the sharpened end of a Q-tip stick into deoxit and use a combination of localized mechanical and chemical cleaning. I've seen in the past where the material that band switch wafers are made of is very absorbent, and when you spray it with deoxit to clean the band switch, the wafer will distort or suck up the solvent like a sponge and misshape. So, like I said, when possible, you want to avoid that. Next, I'm checking the canned ohm multi-section wire wound resistor. This resistor is used as a voltage divider in the set's power supply. Canned ohm resistors are a somewhat failure-prone component, but this one checks out just fine, so it's staying in the set. Getting dizzy? Like most radios of the early to mid 1940s, this set made extensive use of wire insulated with a type of gum rubber that did not fare well with the passage of years. Any radio made between about 1939 and 1950 is susceptible to having lots of wires inside whose insulation is crumbling and falling off. This was the case with this radio. A previous owner sprayed a red-colored spray adhesive all over the inside of the set in an effort to arrest the decay of the crumbling wire. I spent countless hours cleaning this stuff off the components, wiring, and chassis. Here you can see me scrubbing it off the chassis with a Q-tip soaked in acetone. I'll only show a minimum of this so as not to induce coma. Capacitor and resistor replacement was standard fare for the most part, but there were a couple of issues unique to this radio. That being said, I won't show the whole process as it's been covered to death in radio restoration videos here on YouTube. Here's what the recapped and cleaned chassis looks like underneath. My method of capacitor and resistor replacement involves completely removing the old component from its tie points and installing a new one in the same fashion. I do not use the J-hook or squib method as I feel it looks shoddy. That's not to say it isn't a viable method of replacing components. I personally just don't like the looks of it. It's just a matter of personal preference. There is one special capacitor in the set that required a little creativity. C27, a 0.01 microfarad 400 volt capacitor going from the volume pot's wiper to the grid of the first audio tube, is a special shielded capacitor. I figured a thin brass tube would be ideal to mount the modern replacement capacitor in, so I started looking around the hoard in my workshop to find an appropriate brass tube. As so often happens, I had parts larger than what I needed and parts smaller than what I needed. Inspiration struck me, though, when I glanced at some reloading equipment in a cabinet and decided a 223 Remington cartridge would be the perfect candidate for a shielded sleeve. It's just the right diameter, and you can solder directly to it. I chucked the case into my bandsaw and lopped off the rim and shouldered neck to leave behind a nice tube as you see here. I soldered a short bit of braided wire for the ground directly to the side of the case. The capacitor was then hot glued into the center of the brass tube and then installed in the radio. The braided pigtail was then soldered directly to chassis ground. Defective wire was replaced where necessary in the chassis, as well as connecting to the speakers. Here I'm replacing the crunchy solid conductor speaker wires with modern copper stranded wires. Phasing is an important aspect of the way the speakers work in this set, so you'll notice the crossover of the wiring has been preserved. That's about it for this video. Stay tuned for the next part where we'll cover cleaning the chassis, restringing the dial cord, as well as the set's first power-up. Thanks for watching.